Hello friends and welcome to this video. I am Lawrence the Wonder Boy, the Prodigy, and in this video, I will answer 20 beginner questions about 3D printing. I hope I can make starting with 3D printing a little easier for you.
What exactly is 3D printing and how does it work?
3D printing is basically the exact opposite way of manufacturing parts. You might know it from CNC milling, lathes, a file, or a kitchen knife. With all these, you can make things, and 3D printing does exactly the opposite. Instead of removing material, we add it. Components are created layer by layer in individual layers. What 3D printing processes exist and how do they differ? There are basically three 3D printing processes. And the most common is FDM. You probably already know it. In FDM, a so-called filament is used. This is basically the ink for the printer, which is melted using heat and built up layer by layer. In SLS printing, which mostly involves very large industrial machines, a powder is melted using heat and a laser beam. SLA printing is based on a UV display with a specific epoxy resin that hardens with UV light and thus builds up layer by layer.
Which printer is best suited for beginners?
The FDM printers are best suited for beginners. They are cost-effective, easy to use, and allow you to quickly and easily build nice parts at home. For example, figures, spare parts for any refrigerator, a car mount, or many other things.
What print size do I really need?
The print size doesn't actually matter much. You should start by buying a high-quality small printer instead of a big cheap one. But first, you have to ask yourself, what do you want to print? Small figures, large parts to organize drawers, or maybe spare parts for cars, then it's better to get a closed printer. Think first, then buy.
What materials are available, and which ones did I use before?
There are so many different materials that it's easy to lose track. The most common material is PLA. It is even biodegradable, making it a truly beginner-friendly material. You don't even need a heated bed. The nozzle temperature alone is enough to melt the material. Then there is, for example, PTG, a very common material. Your water bottles from the supermarket are made from this material. Very flexible, durable, and suitable for almost everything. Then there is also, for example, ABS, which has very high temperature resistance and is also UV resistant. Additionally, there are PA, PC, and PPA, which often contain carbon fiber, making them extremely stable and heat resistant, but also very difficult to print. So for beginners, start with PLA.
What nozzle sizes are available, and what do they offer?
Nozzle sizes range from small to very large. The most common size is 0.4 millimeters, slightly less than half a millimeter, which is already quite small. But that's the common size. There are also 0.2 millimeters nozzles, intermediate sizes like 0.3 millimeters, as well as 0.6, 0.8, and 1 millimeter, theoretically up to 1.75 millimeters. You would then feed the filament straight through, so choose a nozzle smaller than your filament diameter. There are also larger filament diameters like 2.85 millimeters. For example, you can use a 2 millimeters nozzle, but that is rather specialized. So you can say that 0.4 millimeters is the nozzle used by 90% of all 3D printers. Small nozzles are used for fine details like small miniatures, and the larger the nozzle, the rougher the layers become. That means if you want finer layers, you use a fine nozzle for small parts, and for large parts, you use a slightly larger nozzle, for example, 0.8. Then the print finishes faster, but also consumes more material and ultimately looks a bit rougher.
How much electricity does a 3D printer consume?
A 3D printer basically consumes about the same as a PC, somewhere between 50 and 150 watts. Depending on the build volume size, the bed heating, and the material used, specifically the temperature the material requires, it consumes on average 50 to 150 watts, which really isn't much when you realize you can build such great things quickly and easily with it.
How loud is a 3D printer?
A 3D printer is about 40 to 65 dB loud, making it only slightly louder than a microwave or a regular fan, and clearly quieter than a vacuum cleaner. Basically, the 3D printer with its motors isn't actually that loud. It is usually the fans that are loud on the 3D printer. So the higher quality the printer is, the quieter the fans usually are. Prusa printers, for example, have special fans from Noctua, which are known to be very quiet. A Bambolol, or quality printer, usually even has side turbines that ensure the components are properly cooled. However, These are significantly louder in contrast, so consider which printer is best for you.
How fast can a 3D printer print?
That entirely depends on your 3D printer. The somewhat older entry-level devices print at somewhere between 40 and 80 millimeters per second. Nowadays, the printers are already significantly faster. Now, they can print more, like between 100 and 200 millimeters per second, which is really fast. And if you consider that I personally started at just 50 millimeters per second and now can print with a printer averaging 150 millimeters per second, then that is already a huge leap, because today the parts are finished more than twice as fast and just as stable as before.
Do I need a heated print bed?
A heated print bed is only necessary for materials like PG, polycarbonate ABS, ASA. For PLA, for example, it is not strictly necessary, but I would definitely recommend a heated bed because it ensures that I can remove the part from the bed much more easily after printing. And folks, I'm speaking from experience because I've had to hammer some parts off my heated build plate, and that was not cool. So very important, a heated build plate, and make sure your 3D printer also has a spring steel sheet on top, which you can magnetically attach to the plate and thus flexibly deform, making it really easy to remove the part in the end.
Which software do I need?
Basically, you really only need the appropriate slicer for your 3D printer. At Prusa, it's the Prusa Slicer. At Bamulab, it's Bamu Studio, and many others like Quality Studio, Anycubic Next. All of these are slicers where you take the parts, that is, the 3D models, which you can usually download for free from the internet, and optimize them for your specific printer so that the printer knows exactly where to move to build the part. There, you also set the nozzle temperature, the bed temperature, the speed, and the material you use. What resolution should my part have? That is the layer height. Does my part need support structures? Do I need a brim, that is a border? If the part tips over, you can set all that in the slicer, which is the most important program you need to get started. If you want to further educate yourself and create your own 3D print files, you will also need a CAD program like FreeCAD, or, for professionals, Fusion 360. With that, you are covered.
How much does it cost to get started with 3D printing?
Getting started with 3D printing is actually not that expensive anymore. Good printers nowadays start between 200 and 500 euros, depending on whether you want a large build volume or perhaps want to print more detailed models. For example, the Bambolet is a very good entry-level series since it is first of all cost-effective. The printers are high quality, unfortunately made in China, but they are incredibly user-friendly and provide the perfect introduction to the world of 3D printing. If you're looking for a more advanced printer, then check out Prusa. These are printers for life. They can always be upgraded from the older to the newer generations. That means you never have to replace the entire printer when it becomes outdated. They are extremely robust and withstand thousands of printing hours. Simply workhorses. That's why you often see Prusa printers in my background and somewhat fewer Bambolet printers. But that doesn't mean Bambolet printers are bad. There are many others like Anycubic Quality and much more. If you naturally also need accessories like isopropanol, tools, or a filament dryer, then you naturally end up with a somewhat higher amount. But if you can spend about 500 euros, you can definitely get started. But of course, it doesn't end there, because somewhat larger multicolor printers, like the Prusa XL, can easily cost around 400-500 euros, plus accessories, plus a base, plus so many materials. It can get quite expensive. But when you compare that to industry, entry-level printers for private individuals have become very affordable, because industrial machines can quickly cost six-figure sums.
How precise are 3D printed parts actually?
3D printed parts are only as good as your 3D printer is. Cheap 3D printers often have larger tolerances than expensive ones, but fundamentally, they all produce very detailed parts. What do I mean by detailed? Well, everything under 1 millimeters. Here, precision is already in the range of tenths of a millimeter, which is extremely accurate. But this assumes that his printer is well maintained and perfectly calibrated, that many parameters are calibrated and you know exactly which settings you use. Temperature, print flow, all these values are crucial for a perfect component. Nowadays, there are additional sensors that can further calibrate the whole process. But by and large, 3D printers are already extremely precise, because the 10th millimeter range is practically like a human hair.
What post-processing is necessary?
Most FD components no longer require post-processing. Of course, there are types of post-processing, like some sanding, some painting, or also thermal treatment. There's a lot of that. But basically, FD components do not need to be reworked, unless you prefer a bit of texture. For SL components, it's a different story. These parts still need to be washed, soaked in pure isopropanol, and then post-cured under UV light. For SL components, the parts must first be freed from any residual material. Then they have to be blasted, and only then can they be colored. So considerably more complex.
What adhesion problems occur during printing?
Adhesion problems are an absolute nightmare for every 3D printer. Because if the 3D printer has adhesion problems, that usually means the complete failure of the part we are currently printing. The edges lift up, causing it to detach and possibly fall off completely. It can be dragged along with the print head. The nozzle can become completely clogged with material from the entire head. Really, really bad. So clean your 3D print beds regularly with warm water and soap, or with isopropanol to ensure optimal adhesion of your parts on the build plate.
How long does a nozzle or a print bed actually last?
Standard brass nozzles wear out relatively little when using standard materials like PLA, for example. But if you print with materials like PTG, CF, or PLA 12CF, always be aware that CF, GF, as well as glow and glitter filaments are all abrasive filaments that would significantly wear down your standard brass nozzle over time. Therefore, you should definitely use a hardened nozzle, such as a hardened steel nozzle, a stainless steel nozzle, or even diamond nozzles, or hybrid nozzles with silicon carbide inserts. It's all very technical, but basically works for almost any material. The standard brass nozzle, I personally replace it every few months in my production, but my printers are also heavily used.
How do I store filament properly?
Filament storage is one of the most important questions you should ask yourself. Where is my filament stored? It is humid, it is exposed to a lot of dust, possibly even exposed to UV radiation. Always make sure that your material is packed dust and airtight, and so that it is stored dry as well. Put a packet of silica gel inside, dry your filament before you store it, or before you want to use it again. And you should never place it on a windowsill, but rather in a black box under your table, under your Renrad rocker, because only in this way can you ensure that your material lasts as long as possible and always prints well.
What safety aspects do I need to consider?
Safety is a major issue with 3D printers. After all, we have motors, we have heated elements, we have fans, a lot of movement, and a lot of electronics, which naturally poses a high risk. Guys, I don't want to scare you, but better have a fire extinguisher nearby. No, just kidding, don't worry. Of course, safety should not be neglected, but by and large, 3D printers are extremely harmless, because after all, they are made for us at home.
How sustainable is 3D printing actually?
3D printing is becoming more and more sustainable day by day, because more and more companies have specialized in this, recycling our filament or part leftovers, and processing them into new filament. PLA, for example, is already a biological material, which is already very, very good. But not only the filament can be available, but also the electricity with which the printer is operated. For example, with solar energy. So put a solar panel on your porch roof, and then you can produce climate neutrally with your own generated electricity. Also, maybe choose a printer that can be easily repaired and upgraded, such as the printers from Rosa. When a new model comes out, you can buy yourself an upgrade kit and bring the printers up to date. That is also sustainable. And make sure the printer preferably doesn't come from overseas, but maybe comes from an EU country, who also produce the printer in a climate-neutral way. And the delivery route to your home is not too long. All these are things that make 3D printing climate-neutral.
What can I actually do with 3D printing?
I have often been asked that question. With 3D printing, there are practically no limits. You can print anything, from toys to miniature figures, spare parts for cars, household items, various t-shirts. You can print prototypes from so many different materials, PLA, CB, SES, with carbon fiber, with glass fibers, glowing, from all imaginable materials. Things can now be printed. So you can already tell everything is possible. In the industrial sector, partial printing is even possible, using materials like aluminum, steel, stainless steel, even titanium, with which bones can be printed on plates for medical purposes. One can print teeth on plates. Even the aerospace industry now uses it. Parts from 3D printing. You can already tell, 3D printing ranges from hobbyist basements to high-tech industry, found everywhere. And there are almost no limits. Because with 3D printing, you can also print components which you cannot make with other conventional machines, which you cannot produce at all. That's it for this video. something a bit different. I hope I was able to reach a few beginners this time as well, of you out there. If you don't know me yet, I am Munzalius, the Prodigy, and you always see me on Wednesdays and Sundays. Here I am in a 3D printing workshop, producing videos for you about how I build my 3D printing business. Which are the newest printers, the newest materials. I will explain everything to you, step by step, and am here for you. Thank you very much for watching. If you like the video, feel free to give me a thumbs up. Subscribe to my channel so you don't miss anything. And as always, my friends, see you soon.